Well, we made it to the last lesson of Chapter 9. Today we're going to talk about 11.9, solving these equations that have radicals in them. Well, before we get started, we have to talk about this idea of an extraneous solution. So an extraneous solution is basically a false solution. So radical equations, because of what we have to do in order to solve a radical equation, we may introduce some false solutions. Basically, you get an answer for x that if you plug it back in, it does not work out. So what that means for us, and I'm sure you guys will be really excited about this, is every time you get an answer, you actually have to check it. You have to plug it back in and see, does it actually work out? Alright, so here's our first radical equation. We call it a radical equation because it has this radical, the square root symbol, in here. To solve the radical equation, you do want to isolate the square root. So you have to get this by itself before we undo that. So if you see anything on the outside of that, for example, we have this minus 3, you want to get that to the other side. So we're going to add 3 to both sides first, leaving us with the square root of 2x equal to 10. Alright, so now it'd be great for us to get in there and get to the x, maybe get rid of the 2, but before we can get inside the square root, we have to actually undo the square root. So what's the opposite of square rooting? Squaring. So we're going to square both sides of this equation. Now if you remember, if you square a square root, they basically cancel each other out, and we end up with just what was on the inside, the 2x. And then on the right side of our equation, 10 squared is 100. Now our equation, one more step, easy to solve. We'll divide both sides by 2, and x is equal to 50. But is x actually equal to 50? I'm putting a question mark because we do not know until we do our check and we plug it back in. So yes, it's a pain, and yes, you have to check all your answers. So all that means is you're going to plug in a 50 for the x. So we have the square root of 2 times 50, and then we have this minus 3 equal to 7. And I'm just putting a question mark above the equal sign because we want to know, is it equal to a 7? So all that we're doing is we're simplifying this left side. First we have 2 times 50, which gives us 100. So the square root of 100 minus 3. Is it equal to 7? Well, the square root of 100 is 10. Minus 3, is that equal to 7? And 10 minus 3 is 7, which is equal to 7. So our answer did work out. It was not a false solution or extraneous solution. So x equals 50 is our true answer. But again, we didn't know that until we showed this work, which you do have to show on all your problems. All right, so here's another one. We've got our square root up here, square root of x. We want to get that alone before we do any solving. So if you guys have an equation that has a big fraction like this, your first step you're going to want to do is undo that fraction. So we're dividing by 4. Let's go ahead and multiply both sides by 4. That allows us to cancel out those 4's, leaving us with 3 times the square root of x is equal to 12. Now again, we're trying to get the square root by itself before we undo that. So that 3 that's out front is being multiplied. This is multiplication between the 3 and the square root of x. So we're going to divide both sides by 3 to get rid of that. So we have the square root of x is equal to 4. Now we're ready to undo our square root. So we're going to square both sides. The square, if you square a square root, or the square root of x squared is just an x, equals, and then 4 squared is 16. So x equals 16. But does it really equal 16? We're going to plug it back in and see if it worked out. So you just plug in to where the x is. So I'm going to put a 16 in for the x, and basically just simplify that side and see if you get a 3 on the right. I don't want you to try to get any of these numbers over to the other side. We're not trying to solve anything. We're just trying to simplify the side where your x is. All right, so we have 3 times the square root of 16 is 4 divided by 4. We want to know if that equals 3. 3 times 4 is 12 divided by 4. And 12 divided by 4 is 3, still equaling the 3 on the right side. So if you notice, I just carry this 3 down each time, and I'm only working on simplifying the side where we plugged in the x. And it worked out, meaning this is a true solution. This one did not have an extraneous solution. All right, this is the last example of the intro video, and then there's a few more good examples in your follow-up video. So here we have a radical equation. Already it looks a little bit different. You've got two radicals right here. So what do? How do we solve this? Before we were saying to isolate the radical, so you do want to isolate the radical. Let's say I go ahead and I pick this one. I want that one to be by itself, which means this second one has to get to the other side. So I'm going to go ahead and I'm going to add it, because we're subtracting the square root of x plus 3. You can go ahead and add the square root of x plus 3 to both sides. They cancel each other out on the right side. On the left side, 0 plus the square root of x plus 3 is just the square root of x plus 3 equals the square root of 2x. So if you noticed, we got this square root of 2x by itself, and it helped us out because it actually got this negative square root of x plus 3 over to the other side. All right, so now we're able to continue solving. We want to solve for x, but we have the square root, so we're going to go ahead and square both sides. This actually helps us out with both of our radicals. You square a square root on the left, they cancel each other out, leaving you with just the x plus 3. And then on the right side, we square a square root, leaving us with just the 2x. All right, so now we're going to solve for x. Get your x on the same side, so maybe I'll subtract x from both sides. 3 is equal to 2x minus x is just a 1x, so we got x equals 3. But does x really equal 3? Well, I don't know. That's what we have to check. You can't just assume that this is going to work out every single time. And if you want full credit on any quizzes, tests, or homework, you do have to show this work. So when you check your answer, you have to go back to the original problem. You don't want to go back to any part of the problem where you already started doing some solving. You have to go back to the original. So we're going to plug in, here's our check, 0 equals the square root of, what do we get, 3? So 2 times 3 minus the square root of 2 plus 3. All right, so 0 is equal to 2 times 3, square root of 2 times 3 is 6, minus the square root of 2 plus 3 is 5. And I actually just paused the video because it seemed a little bit weird. Did you guys find my mistake that I made? I actually found it this time. So be careful when you're plugging in. We said that x is equal to 3, right? And then what did I do up here? I plugged in a 3 for this x. That was correct. But then over here, I plugged in a 2. I don't know why I plugged in a 2. It's just we make mistakes sometimes. So that should be a 3. All right, so then this becomes a 3 plus 3, which is 6. Hopefully we can see this okay. All right, so we keep solving. 0 equals, what's the square root of 6 minus the square root of 6? Well, that equals 0. So this one worked out also. So is our answer x equals 3? Yes, it is, because we checked it and it's correct. Now, are they all going to work out? No. In the next video, you'll see what it looks like when one of these solutions does not work out in our check. But you do have to check all of them. So there you go.